to Mr. Plugum. 1. Okay. So I'm going to take my fingers and I'm going to move them from the left and right towards 2. What am I approaching from the left? Approaching x equals 2. What's the function approaching? 1. What am I approaching from this direction? 0. I'm approaching 1 from the left, 0 from the right. Therefore, Mr. Plucker, what's the answer? What's the limit at 2? No, it's not 0. It's not 1. The limit does not exist. The limit has to be the same from the left and the right. So if you sketch it and you end up with something that looks like that, the limit does not exist. Yes, ma'am. Yep. Doesn't matter. Except they'll never put that on a test because that wouldn't be a function. Yeah. Now they might put 2 open circles, which doesn't change the answer to the question or the question at all. It's still a function because there's no overlapping. Remember, it's vertical line test. Get the same principle. So they do this on the test. They say what's the limit, and the limit still does not exist, right? You're still approaching 1, you're still approaching 0. It's still the same question you just asked. Yes?
Why did you graph it like that?
Okay, the piecewise function, now graph piecewise functions.
Oh my, okay.
It says f of x is 1, where x is less than 2. The only thing that's weird is that line down there. I think that's just because at some point the way word processor said, well, that must be a fraction.
That's fine.
Is that okay?
Yeah.
Okay. All right. All right, number 2. Everybody try the following. Graph y equals 1 over x. You want to find the limit, x approaches 0. So graph y equals 1 over x. This is a graph you should already be familiar with, but if you're not, now's a good time to get familiar with it.
Whoa. This one violates the first and the second.
The first and the second rule. Both of them? Both of them.
Yes.
Violates 2 rules at the same time. That's amazing.
No, it's kind of cool.
So, as x approaches 0, what's the function approach? I mean, nothing. The limit does not exist. Why? Goes on forever and ever. Never, never. But never touches it. You go to 2 different places, one way to say it. Also, if it goes to infinity, the limit does not exist. So for both of those reasons. The limit does not exist. Thank you. Yes. Doesn't it come one way? So not approaching the same number, which is one reason to say it. The other reason is if it goes to infinity, it still doesn't matter. It's also the limit does not exist, correct? So for those 2 reasons, the limit does not exist. It goes to infinity and it goes to a different infinity, which means going left and right, going to different places. Both those reasons, this is the limit does not exist times 2. It really, really doesn't exist. I'm making fun here. You good? Fine. You're okay? Yes. Well, we're talking at x equals 2.
Okay.
On this function you just did, we're saying that x equals 0. Any place else, the limit exists.
Yeah. Okay.
But x equals 0, the limit does not exist.
Yeah.
Right? I have to tell you where I'm looking, checking for the limit.
Yeah, I see.
Okay. All right. Number 3, I pre-graphed it for you. Number 3, I pre-graphed it for you basically because if I don't pre-graph it for you, I spend an hour telling you why your TI is a piece of junk. It won't give you this graph necessarily.
It didn't
It
graph
might.
I don't get it.
Yeah, isn't that nice? Love TIs.
Why is it just...
Sell TIs.
Oh, it's
Just go to the store and sell it right now. Stay in the corner and see if you get a nickel for it. Just kidding. So the graph would really look like this. If the graph really looks like this, what's the limit?
The limit, isn't it just 1?
1. It is not existing.
The
Wait.
limit is 1,
Wait, I can't.
or is it 0? You
As,
can't.
as x approaches...
And the answer to the question is x approaches 0.
Okay.
What's the limit?
It looks like 1 and negative.
Well, what's happening is
Yeah,
you look
what's 0?
inside the function. What's really happening is you're making the amplitude 0. No, I'm sorry, not the amplitude. The period 0. Which means it takes 0 to go up and down.
oscillating.
So at the middle point,
Is that how it's
it's going straight up and down the whole entire length. So if you have a function that starts oscillating faster and faster as you approach the value, you're not approaching one value, you're approaching lots of them. And so we would say in that special case, the limit does not exist. You're not approaching one value, you're approaching multiple values. Yes, ma'am?
Since it changes so quickly, does it still pass the vertical?
It would not. At the very center, it would not pass the
So
vertical
it's
limit.
not a function.
It would not be a function. But it fails it instantaneously, which leads to a great bit of fight amongst math, if that's just whether you can actually say it's not a function.
It's a regular sine graph.
That's fine. It's the fact that it's oscillating faster and faster and faster means it's got all those values, right? If it's a normal sine curve, it's easy to find them. It's not that bad. And by the way, this is a super special case. I don't think I've ever seen on the AP test, but they tell us you have to teach it to you. So sometime or another, somebody's going to read the little book and go, oh yeah, we've been asked one of these questions in 53 years. Let's bring it on this year's class.
Why would they do that?
Because in the AP Calculus AB test, they have about 28 good questions every year. Then there's 7 they're kind of going, what are we going to do here? That's when the bad stuff happens. All right, flipping it over, you should be able to do 13 through 18 now.
What is the
Very good.
Because you don't listen.
Yeah, I just looked at one.
So there cannot be two limits.
They can't have 2 different limits. They have to be the same one, same place. So in case of 13, everybody, the limit does not exist. Also, look at that absolute value form. You see that a lot. Okay, so if you see them that looks like that, at the point where they are the same, whether it's 0, 0, that's where the limit does not exist.
I think so.
No, it's as I approach this side and I approach this side. What number am I approaching this side? I'm approaching -1. Approaching this side, I'm approaching 1. Those are the same number, so the limit does not exist. Then the fat guy at the table that's balding, you got to read 10,000 tests in the next hour and a half. Gets to decide whether or not you wrote the limit does not exist. You're under his mercy at that point. Because whenever he decides, oh, you know what, Mr. Cardell, you stay put. Do you have your little card? How do I scan it? You have your little card? You just put the card on the machine? No, go. No, you're right. Here, go. This is too hard for you.
I guess.
You're supposed to be one on the 3rd floor, so if you do it right away, you can get the first or 3rd floor. But I haven't seen anybody on the 3rd floor. You guys?
I saw it this morning.
Yeah, you're gonna have to go to the 1st floor this late, I think.
Well,
I
I
used
just
to
thought
go
I
for
found
one.
like what's it like someone like
It's an
yeah, sorry.
Yeah. You have this That's why I'm telling you, look at that right picture where it said, yeah, you should. Look at that. It's going to be stable. In that case, you might have to draw a dot. Plug it back. You know, well, do you know what an absolute value? I would tell an absolute value. Just to read. So that's wrong. You learn how to do that. You can write it as this or that. You can write it as negative x plus 5 over x minus 5. And x plus x minus 5 over x minus 5.
No.
We weren't supposed to do that. It's much less than that. And then you try to do that. That said, I don't say guarantee it's a what?
It's like that.
It's like this.
Tornado.
Bro, I wonder what
It's this long, but
That's the kind of leaving I was going to agree with. I was thinking we're in the old schedule last year, like have class. No! Just make sure you give me like 5 minutes. Anything else? I know. Good. That's when infinity is going to negative infinity. So what do we say?
Physics.
Limit as x approaches 3. What do we say? Limit does not exist. One's going to infinity. There's one reason. Otherwise, they're going to different infinities. They have to go to the same place. Exist. So those 2 reasons. Are you on your phone during my class?
Look, my closet.
Thank you.
My
Now I've got a cat, a scary looking cat.
That's not scary.
He's taking over the bed.
I've seen this.
That's so scary. Did you have to put it down, or you thought I will control what you did to take care of your cat? That's somebody else's cat that was in your bed?
Someone else's son.
In their bed? Is that like a plea for help? Did you go send the police to their house?
Yeah, how is it?
No? Alright. Obviously you don't care. Alright! I passed out the problem of the week 103.